In this video, we'll talk about congruence and kind of how it can be useful and how to really write congruency statements. So first off, let's talk about what it means. Congruence is, for lack of a better term, it's a way of saying that two geometric shapes are quote-unquote equal. But what does that mean? Well, it kind of means different things for different objects. If I'm talking segments, well, it means they have same length. If I'm talking angles, it means they have same measure, meaning they're both same amount of degrees, per se. If I'm talking about polygons, and we can expand this to other shapes as well, it means that they have the same side lengths, and they have the same angles. And what I really should specify here is that they have same corresponding angles and side lengths. We'll talk about what that word means. So if we're talking about congruence, in particular we talk about, let's just talk about two segments for now to kind of make this a little bit simpler for starters. So if I have two segments that are indeed the same length, so let's call them AB and XY, and let's just say for the sake that they're both 7 units in length, then I could write this as AB, the segment, is congruent to XY, the segment. And I would write it this way so that I can show these two things. And this symbol right here is shorthand for congruent. So I'd read this: AB is congruent to XY, meaning they are segments, they are both the same length. Now we've talked about it a little bit differently with angles versus triangles, and we'll talk about that in a couple other examples. So let's talk really quick about angles. So if two angles are congruent, that would mean they have the exact same angle measure, much like two segments would have the exact same measure if they were congruent. So for me to write this, I have to be a little careful here with the order. We're talking about angle ABC, and that order is important because B is the vertex. It has to be the second letter in the angle. And I can say this is congruent to angle XYZ. Now again, I have to be very careful with the order in that Y has to be in the middle. If that's not the case, I'm not talking about those two 32-degree angles. But again, we can use this shorthand. The order kind of matters a little bit more in this case than it does with the segments. All right, now let's talk about what happens if two triangles are congruent. So if two triangles are congruent, well, that means that their sides, they have to have same sides, and they have to have same angles, meaning those are congruent. So I have to be careful here because we are talking about not necessarily all the sides are congruent to each other, but we're talking about pairs of sides. So like for instance, let's say AB is congruent to XY. Now these two sides are what we would call corresponding. And the best way I can explain corresponding sides would be if you were to do a rigid motion of some sort with triangle ABC to where it would line up with XYZ, well then AB would line up perfectly with XY. So in this case, it kind of looks like a translation. And if we were to slide AB to the right, it would line up perfectly with XY. Likewise, we can say, or let's say, that BC was the same as YZ, and AC is the same as XZ. Okay, now if we're talking polygons, we need more than just the sides. With a triangle, it's enough to make that deduction, but for the sake of the sake, we also need to say that the angles, the corresponding angles, are congruent. So again, very similar to the sides, we have to have these angles that are congruent pairwise, meaning that angle A is the same as angle X, angle B is the same as angle Y, angle C is the same as angle C or Z, but notice that angle A doesn't necessarily have to be congruent to angle C. We can have a little bit of variability there. So like for instance, if angle A was 30 degrees, well then I could say angle X is also 30 degrees. If I know angle B was 100 degrees, I could say angle Y is also 100 degrees. If angle C is 50 degrees, well then I can say angle Z is 50 degrees. We can make those leaps. They're what we call corresponding congruent angles. Now, when we're writing a congruent statement, a shorthand for triangle is a little triangle like this. So triangle ABC is congruent to, now I have to be very careful with the order here. A and X are corresponding parts. So then if A came first, X must come first in my congruent statement, so that these statements will show these are corresponding parts. And then likewise, B and Y are corresponding. So since B came second, Y must come second in the congruent statement. And then likewise, C came last, so Z comes last. And that would be a way I can write that those two triangles are congruent. So there's congruence, kind of in a comprehensive nutshell. It's what it means for different objects to be congruent, and it depends whether you're talking segments or angles or polygons, but the idea is that they are the same. And that can mean different things for different objects in geometry. So just be aware of it. When you're talking congruence, it means that they are exactly the same. They might be oriented differently, they might be spun around, they may be reflected, but they are still the same.